Okay, guys, sorry the audio wasn't working. So I'm going to make you guys a short video real quick just to give you guys the basic groundwork for stoichiometry, okay, how it works and how we use the mole ratios. Now, it was requested that I do a video on balancing, so I'm going to go ahead and include that here. Okay, so the balancing equations basically means that you need to have the same amount of elements on the reactant side, which is this side, as you do on the product side. Now, let's go ahead and list all the elements that are involved in this reaction. We have carbon, we have hydrogen, and we have oxygen, okay? So the best way to balance this, right, is first off, we need to figure out how many of each are on each side of the reaction, right? So on the reactant side here, right, how many carbons do we have? Well, there's no number there, so we can assume 1. Hydrogens, this number tells us that we have 4. And then oxygens, this number tells us that we have 2. So these are the amounts that we have on the reactant side. If we do the same thing for the product side, carbon, we have 1. Oxygen, we have 2, plus 1 more is 3. And then hydrogen, we have 2. Hydrogen, we have 2, okay? Okay, so here's what we need to do. In order to balance a reaction, right, we need to add coefficients. And coefficients basically just change the number of molecules, right, and in turn change the number of atoms on each side of the reaction. Normally, I would say start with the one that has the lowest amount, right, overall. So like if you notice, oxygen in total has 5, hydrogen has 6, and then carbon has 2, right? Well, these two guys are already in balance. Because oxygen is by itself here, we're gonna go ahead and we're gonna start with hydrogen, and you'll see what I'm talking about in just a minute. Okay, so here we have 2 hydrogens, and here we have 4. So if I wanna get these two numbers to equal, what I'm gonna do is I'm gonna add a coefficient of 2. Okay, I'm gonna add a coefficient of 2 right there. Now what that does is it affects the number of hydrogens in my reaction. So now 2 times 2, instead of having 2, I have 4. Okay, but this 2 also affects the oxygen, right? So now I have 2 times 1, that's 2, plus 2 more from here, that gives me a total of 4 oxygens. 4 oxygens. Right? So by putting 1 into balance, I've actually further out of balance another atom. So now I have to go back and rebalance the oxygens, okay? Let's take a look here. So if I have 2 oxygens, what coefficient can I multiply by 2 to get me to equal 4? Well, the answer is just, I put another 2 right here, right? 2 times 2, that gives me 4 oxygens. So I have 1 carbon and 1 carbon, that is balanced. I have 4 hydrogens and 4 hydrogens, that is balanced, right? I have 4 oxygens and 4 oxygens, that is balanced. So this has now become a balanced chemical equation. So if I wanted to rewrite it, it would include these coefficients, okay? And this is what I'm talking about when I say coefficient. Now, you can only add coefficients to the beginning of a molecule, okay? And this affects everything in the molecule until you hit another plus sign, for example. So like if I was to put a coefficient here, it would affect, if I was to put a coefficient here, for example, it would affect everything here, and its effects would stop at the plus sign, right? It only affects these guys here. All right, so a coefficient affects everything in the molecule. All right, so let's rewrite our equation. Okay, I hope that helps you guys with the balancing. Okay, so CH4, the computer does that. I don't know why it does that to me all the time. CH4 plus 2O2 yields CO2 plus 2H2O. This is our balance reaction. And this is what we're going to use to answer this question. The question says, how many moles of oxygen are needed to completely combust 0.850 moles of methane? So I have 0.850 moles of methane. And I want to know how many moles of oxygen I'm going to need. Okay, so the first step to figure out is which two elements or which two molecules are we working with? In this case, we're working with methane and oxygen. So the first thing I'm going to do then is I'm going to find the mole ratio there. I'm going to find the mole ratio. Okay, the mole ratio from methane to oxygen is as follows. I have 1 mole of CH4 to 2 moles of O2, right? Or I can have 2 moles of O2 to 1 mole of CH4. This is exactly the same thing. Okay, exactly the same thing. Okay, so now we've identified the mole ratio. Okay, so let's set up the problem. Let's set up the problem. Okay, so the mole ratio is used to find an unknown quantity from a known, right? So the unknown in this case is the O2 and the known is the CH4, okay? So the way you set up your problem is you take the given, right, or the known, put that over 1, then you're going to multiply by the mole ratio. You're going to multiply by the mole ratio to find the unknown. Now, the unknown should end up here. This should be your unknown. This is what we're looking for. So this is the basic model that we're going to use to figure out the unknown. Okay, I'm going to scroll this up a little bit. So we know that we have 0.850 moles of CH4. This is our given. And we're going to multiply that by the mole ratio that we just found. Now, you have two choices in mole ratio. You can either use this one or you can use this one. The way you know which one you use, right, is the unknown should be at the top, or whichever one is here, that should also be here. So in this problem, right, to set it up correctly, I'm going to use this mole ratio for 2 reasons. Reason number 1, it has my unknown at the top, right? This is my unknown, right? That's one reason. And the other reason is because my given is at the bottom. And we need the given or the known at the bottom so they can cancel each other out. So this is how I know which mole ratio to use. So all I'm going to do is just put it in there exactly as it appears. Of O2, right? And 1 mole of CH4. Now look what happens when I multiply this out, right? Already, because these guys are opposite each other, these guys are going to cancel out. Whoa, what happened there? I don't know what that is. Okay, these guys are going to cancel out, right? So because those guys cancel out, then all I have to do now is multiply straight across the top and straight across the bottom. So 0.850, the units are gone now, times 2 moles of O2 divided by 1 times 1, since there's no longer any units there, right? 0.850, that should give me 1.7. 1.7, if I multiply it by 2, right? 1.70 moles of O2 divided by 1. Anything divided by 1 gives me the same number again. So to solve this problem, we use the mole ratio and we determine that we need 1 0.70 moles of O2 to completely combust 0.850 moles of CH4. And this is the product of stoichiometry. Where's the stoichiometry? The stoichiometry is here, right? Because we use the mole ratio to figure out an unknown quantity. And that's what stoichiometry means, guys. You use the mole ratio to find unknown quantities. Okay, that's it. Short video. Hopefully it wasn't too long. If you have any questions, please let me know.